In this video, we're going to review linear equations. So question 1, identify each as an open sentence, a true sentence, a false sentence, or an equation. So it says in letter A, 12 plus 6 times 3 equals 30. Well, if I were to simplify this, 6 times 3 is 18. 12 plus 18 does give us 30. So both sides equals 30, so this would be a true statement or a true sentence. Next one, 5 times 9 is 45. And this is going to equal 4 cubed, which is 64, minus 15. And if I simplify that, 64 minus 15, that would give us 49. And 49 does not equal 45, so this would be a false statement. Next, question 2. Using the replacement sets, -3 and 3, find the solution for each open sentence. So here, I'm going to plug in -3 in for A. So I have 3 times a -3, which gives us -9, minus 5, and this is supposed to equal +4. So if we have -9 minus 5, and that's supposed to equal 4, well, -9 minus 5 is -14. -14 does not equal 4. So we know that -3 is not a solution. Let's try another one. So if we did 3 times 3, and then minus 5, that should equal 4. 3 times 3 is 9. Minus 5, that should equal 4. 9 minus 5 is 4. 4 does equal 4, so the solution for this one would be just 3. Next one, we have 2 equaling 5 times, let's try -3, plus 17. 5 times -3 is -15, plus 17, that equals 2. This side is 2, so we know that works. Now on the other side, if we did a +3, 5 times 3 is 15, and if you add 17 to it, that's going to give us 32. 32 does not equal 2, so the only solution here would be -3. Next, solve each equation and state whether the property or properties of equality are used. So here I need to get f by itself, so the opposite of subtracting 23 is adding 23. So I'm going to do that on both sides. And here I have f equaling 38. So this one I used the addition property of equality. Next, I have k plus 19 equals -12. If I subtract 19 on both sides, I'm now left with k equaling a -31. And since I subtracted the same number on both sides to get my answer, this would be the subtraction property of equality. Next, we're going to solve each of these equations. So here I need to solve for t. The opposite of subtracting 5.8 is adding 5.8. And that's going to give us t equaling 9 plus 8 is 17. 1 plus 5 is 6. 6 plus 6 is 12. So this would be 12.7. Letter B. I need to get f by itself. The opposite of adding 14 is subtracting 14. And f is going to equal a -23. This next one, I need to get q by itself. So the opposite of multiplying by 3 is dividing by 3. Or if I'm dealing with a fraction, that's really multiplying by 1/3. Just know that multiplying by 1/3 is the same as dividing by 3. So now if I simplify this, I'm going to have 5 over 18. And I can't simplify that any further, so that would be my solution. Letter D, here I need to get the a over 2 by itself, so the opposite of subtracting 6 is adding 6, so I add 6 to both sides. And now I'm left with a divided by 2 equaling a negative 3. The opposite of dividing by 2 is multiplying by 2, so I do that on both sides, and a is going to equal a negative 6. Next, here I'm just going to distribute. Here I can distribute, and I can divide a 7 from 7 and 14 and 7. That gives me 2. So then I would have 2 times 5d, or 5 times 2d, it's going to give us 10d. And distribute here, 63 divided by 7 is 9, times 5 is 45. And this is going to equal 10d plus 19. Now to get the d's to one side, I'm just going to subtract 10d on both sides. And I'm left with 45 equaling 19. That never works, so that means there is no solution. And then this next one here, let's just scroll up a little bit here. Here we're going to distribute the 4, and that gives me 12z plus 48 minus 11, and this has to equal 12z plus 37. Now if I combine like terms on this side, I got 12z plus 37, and that equals 12z plus 37. Since both sides are equal, this would be many solutions. Which just means I can put any number in for z and it will work. Next we'll do this one, number 5, find the solutions. So here we have absolute value equations. So I got to make sure I get the absolute value by itself, which in this case it is. And because it's by itself, I can now have two cases. Case 1, I have t plus 11 equals 13. And then I have t plus 11 equals a negative 13. So that's going to be the second case. So the opposite of adding 11 is subtracting 11. I do that on both sides. And t is going to equal 2. Or here I subtract 11 on both sides. And t is going to equal a negative 24. Letter B. Here we have the absolute value by itself. We have case 1, so this is g minus 2.3. This is going to equal 11.5. The opposite of subtracting 2.3 is adding 2.3. And that gives us g equaling 9.2. Now if I do the other case, I would have g minus 2.3 equaling a negative 11.5. I would add 2.3 to both sides. And g is going to equal, since the signs are the same, are different, I would just subtract them. So this would give us a negative 9.2. Next, question 6, solve for the indicated variable. So here we want to solve for a, so we have to get all the a's by itself. So I don't want this bd here, so I'm going to subtract bd on both sides. And now I have az equaling cx minus bd. And to get a by itself, I divide everything by z. And my answer, a is going to equal cx minus bd all over z. In letter B, we need to solve for h. So the first thing I'm going to do is I'm going to divide by 7 first. So I'm going to divide this by 7. Now you could distribute the 7 if you wanted to. I'm just not going to do that here. I think it would be quicker just to divide by 7. So now I have h plus f equals m over 7. Now the opposite of adding f is subtracting f. So if I subtract f on both sides, I'm now left with h equaling m divided by 7 minus f. Now you would still get the same answer if you distributed it. So let me just show you quickly. If you distribute the 7, that would give you 7h plus 7f equals m. To get 7h by itself, you'd subtract 7f on both sides. And you would have 7h equaling m minus 7f. And then you would divide everything by 7. And when you divide everything by 7, the 7's divide out. You're still left with m divided by 7 minus f. Next, question 7. Julio has a rectangular garden plot. He plans on planting vegetables in a triangular partition whose base and height are equal in measure. If the figure has an area of 24.5 square feet, what are its dimensions? So we know this is a triangle. And to find the area of a triangle, it's going to be base times height divided by 2. So now, since we know the area, we know that the area is 24.5. So I'm going to put 24.5 here. And we need to find the base and the height. And then I'm going to have this divided by 2. So now there's a key part in this problem that we have to pay close attention. It says the base and the height are equal in measure. That means if the base is the same as the height, I can substitute h in for b. So I'm going to do that. So right now I'm going to have h times h divided by 2, and this is going to equal the area of 24.5. Now we need to find the dimensions, so here we're going to find the height. So I want to get the h's by itself, so I'm going to multiply by 2 on both sides. And this is going to give me h squared equals 24.5 times 2 is 49. Now to undo a square, you're going to find the square root of both sides, and the height is going to give us 7. Now the square root of 49 can be a positive and a negative 7, but because it's dealing with dimensions, I can't have negative numbers. So the height is 7. So if the height is 7 feet and the height is the same as the base is also going to be 7 feet. So as a review on linear equations.